Right, the first one, A and B naught, A naught and B. A and B naught, A naught and B. Let's use our simulator, right? Let's use our simulator. It's easy. You have two things, A and B, A and B, A naught and B. So let's use A, B, two switches. Let's think that as two switches. This is switch A, this is switch B. And you have to do this using and NAND and NOR both, right? A, B, A, B naught, A naught, B. Right. Again, you have to do, let's apply this another again, just using NOR gate. The first one using NAND gate. So this is A naught and this is B naught. The first one A and B naught, and again using OR gate also, NOR gate using NOR gate. This is A naught, and let's use another one, NOR gate. This is B naught. And our question says you need A and B naught. A and B naught. Let's use AND gate. AND gate means in the first one you have to use NAND gate and NOT gate to make AND gate. NAND gate and NOT gate to create AND gate. But this behave as AND gate. A and B naught. A and B naught. The first one, this is A and B naught. The second one is A naught and B. A naught. Again, you have AND gate. AND gate means NAND gate and AND gate together. Create the AND gate. The second one, A naught and B. A naught and B. That is the second one. A naught and B. You have to make, actually you have to merge this. This AND gate we have done. This is the AND gate. The second AND gate also. Then you need OR gate to combine both. OR gate to combine the first one and the second one. OR gate can be created by using this way. This is how OR gate is created. Unit 3. And you can combine this and this together to create OR gate, and this is the output. Right? So let's see. 0, 0 is 0, 0 and 1 it's 1, 1 and 0 it's 1, and 0 and 0 or 1 and 1 it's 0. Okay, the same behavior. And another thing, actually another thing, so I can tell you another thing now. Actually, if you have here, if you have not gate, this behavior as not gate. This part is also behaving as not gate. If you have two not gates, you can eliminate that. That means you can copy, paste. If you have two not gates, you can eliminate. Oh, sorry, that's wrong. Paste. Right? If you have two not gates, you can eliminate this one and eliminate this one. You can eliminate this one and eliminate this one, and directly combine this one to this one. It will still give the same answer. It will still give the same answer. You can check whether it's giving the same answer. 0, 0, it's 0. 0, 1, it's 1. 1, 0, it's 1. And 1, 1, it's 0. So if you write the second one, that is also correct. Second one is simplified version of the first one. Simplified version of the first one. Who wrote the second one? By cutting this one, not and not, you can cut here because same part. එකම line එකේ not දෙකක් තියෙනවා කියන්නේ not to not you can cut. This one to this one, same behavior. Who wrote second one? Yes, with lesser number of NAND gates. Who wrote the second one? No one. The first one, Sachini. First one you tried? No.
Yes, sir.
Okay. Second one, no.
No.
Right. Second one also you can write down, right? Second one also you can write down. And you can compare this with the original one, right? You can compare this with the original one. So if you want, you can come, but that is not necessary. A and B not, A not and B. A and B not, just AND gate, NOT gate, A and B not. Second one, A not and B. This one, A not and B. You can, this will be merged using OR gate. Right? This is the original one suggested by the other gates. You can compare the results with the original one if you want, because this is simulator. No harm comparing any 0 0 it's 1, 0 1 0 1 0 1 it's 1, all are 1, 0 0 0 0 0 0 all are 0, 1 0 1 0 1 0 all are 1, 1 1 1 1 1 1 all are given 0. So this is the answer. So to create the one mentioned, right, create the one mentioned in the below gate, this is the original one, you can use these two technologies. So kindly draw this and show. This is required because you should know this. Right? I'm going to add this to your solutions. Let's add this and kindly write down all three. All three means the first two is required, right? All three are not required, but the first two are required for this. And there are some other answers. That's why I asked whether you finished. There are some other answers. You have to do the same using no gates. You have to do the same using no gates. Okay, let's do using no gates. Same thing. Now we have to use same thing. You have to use no gates. Let's use two switches. Okay. So first one, no gates. No gates. This is A naught. Sorry, mistake. This is A naught. And same way you can create B naught. This is B naught. A naught, B naught. And then you have AND, A naught and B naught. AND can be created using this way. And can be created using no, no, and no. Three no's. Again, no, no, and no. O can be created. O can be created using two no gates. No and no. That is O. Okay, let's try for this one now. Let's use a bulb. This should give the same answer. Connecting to this one, and the first one is A naught. Okay, you have to combine A naught. It's kind of complex. A naught and B. A naught and B. The second one, A naught and B. The second one, A and B naught. A and B naught. That is the second one. Okay, let's use 0, 1, 0, 0 is 0. 1, 0 is 1. 0, 1 is 1. 1, 1 is also 0. This is using the knowledge. And same time, if there are two NOR gates in the same path, එකම path එකේ NOR දෙකක් තියෙනවා නම්, that will work as NOT gate. So you can cut down those. Just copy this, paste. Sorry, paste it here. Oh. Let's move the interface little up. Okay, here it is. If you have two things like this, you can eliminate, you can cut each. This one can be removed. Oh, not this one. Paste it. Sorry, wrong place. Paste it. Correct place. Use arrows to select. Okay, done. Should see it both. So let's use the arrow. Let's remove this one and this one both. And you can remove this one and this one both. And you can combine this to the second one and this directly to the first one. It should behave in the same way: 1 0 0 1 1 1 and 0 0. So that is the second format. This is the second format. Okay. So all these are similar gates. All these are similar gates. So is it too complex? Right? So no need to draw all, but just remember. So you can simulate, right? Always you can simulate. No need to draw all these, but all are same. All are behaving same way. One is NAND implementation. The second one is no implementation. If you have no gate same path, you can delete. AND gate same path, you can delete. But different paths, no. The not එකකට not එකක් තමයි කරන්න පුළුවන්. But different path it's not. Okay, all these are answers. So let's add to the answer script. And the next one, you can do it alone, I think. Do I need to support or can you do this alone? තනියෙන් කරන්න පුළුවන් නේද? You have to answer, guys. Come on. Can you do it alone or do I need to support for the second one? I'll ask from the one who didn't come last day, Netuli. Can you do this alone, the next one? Or still you need help, Netuli?
Sir, can you do?
Okay, right. But these are easy, right? Only thing is, tapalawa ගන්න නැතුව කරගන්න ඕනේ. නැත්නම් easy. A, B, and C. You have to make it O. Let's use the first one. Let's use. So here you can see the first one is using NAND gate, right? The second one is using no gate. NAND gate is here. This is using no gate. So this is using no gate. Or you can draw no gate one separately. Also, that is also okay. So let's cut and take it in separate way. This is no gate answer, right? For the previous one. For the previous one, this is no gate answer. I'll keep it separate because you can zoom and see them. Okay, now the second one. Let's remove all these things and ready for the second one. A, O, B not, O, C. You have O gate. So let's use no gate. You have three things, A, B, C. First you have to O. A, O, B not, O, C. B is already not. Not එකක් දාගන්නවා නම් ඔයාලා දන්නවා. B not. Combine both together, now it's B not. C not එකකුත් ඕනනේ. C අපි not එකක් හදාගමු. Combine both together, it will create not gate. B not, C not. Now you have B not and C not. A, O, B, O, C. O gate එකක්. O you can create using two O gates. Because first one is no and no එකේ not එක O. This is O gate. You have to create the component and join. Actually, you need three inputs. Let's input. Let's increase to three. So if we are here also, you can improve it to 3 if you want, but all three you have to combine if you want. Right? This is A, O, B not, O, C. A, O, B not, O, C. That is the first one. The second one is A, O, C not. You have cable from A and another O gate actually. O gate can be created using no and no to create O gate. This is two inputs, so A, from here you can just get A, fall down, just move this here, right, A, O, C not, C wala not, this one. And then you have to make this AND, this one and this one AND. AND gate can be created using three NOR gates. ඒවා මතක තියාගන්නවා. NOR තුනකින් තමයි AND එකක් හදන්නේ. ඒක අපි කලින් කරා. Just combine this one and this one together, and this one and this one together. Okay, now we have the circuit. Just combine. Now we have the circuit. Let's use a bulb to test this. You have three occurrences. All three 0. It's 1. First one 1. It's 1. Second one 1. It's 0. Third one 1. It's 0. Then both are 1. It's 1. Here both are 1. It's 1. All three 1. It's 1. So let's draw the truth table for this. Then you can easily identify. This is the truth table. You have 8 combinations, and this is the truth table that you get for 3 inputs. True, false, 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 true, 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 true. The output. Please note the output. True, false, 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 true, 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 true. It's the truth table. So let's try to draw the original one. This is A, B, C. You have B naught, C naught, and the first one is O gate with 3 inputs. You have A, B naught, and original C without not in. Okay, BC. The second one is again O gate. That is basically this one and C naught. Both you have to AND using AND gate. This is without using the universal gate, and it should give the same truth table. So let's highlight this and see whether is it generating the same truth table. Yes, it's True, false, 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 true, 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 true. Here this one also true, false, 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 true, 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 true. Generate in the same truth table. Or you can try. First one, same thing. Both one, same thing. All three one, same thing. First one zero, first one zero, zero. Second one is also zero, second one zero, zero. All three zero, it's one. So it's generating with this truth table. True, false, false, false. True, 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 true. So these two are equal. These two are equal. Okay, if you have here's the clue. If you have not gates in same path, you can eliminate. That means if you have not gates in same path, this one, just copy and paste. Sorry. If you have not gates in the same path like this, you can eliminate. This one can be erased. This one can also be erased. This one can be erased. This one can be erased, but not the others. Then combine this one to this one directly. Should give the same result. You can see if I draw a truth table to this, true, false, 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 true, 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 true. It's still that's correct. All three are equal. So let's take a screenshot of this now. Okay, is it clear now or not? Is it clear now? Netuli, is it clear now?
Yes, sir.
Okay, if not clear, please watch the video again and again and again. Then you'll be able to understand. But you have simulator. You are lucky because you have the simulator, right? You have the simulator, so you are really lucky. So this is the binary version of that. Don't think much about it. This is drawing. Drawing is converted to binary version. Oof, great. Forget it. Just add this screenshot to this one. Because I think most of the students are not doing using simulators. ඉතින් ඒ හින්දා ඔයාලා ඒ ඇඩ්වාන්ටේජ් එක ගන්න පුතේ. ගොඩක් ස්ටුඩන්ට්ස්ලා මේක සිමියුලේටර් එකකින් කරලා බලන්නේ නැහැ නේද? මම දන්න විදිහට පොතේ දුන්නා මේක ඇඳ ගන්නවා. ගොඩක් ක්ලාසස් වල වෙන්නේ එහෙමයි. But this is IT class now. Therefore, please try with the simulator too. Simulator එකක් try කරලා බලන්න. Because that is easy, then you can easily understand this and you can do this faster way, right? And understand easily. Okay, all three are equal. But remember that the middle one is the question, right? These are the answers. The middle one is the question. I'll highlight this using some drawing. Middle one is not the answer, right? Middle one is just the question. I'll just highlight. No shape fill but print. This is just here also. This is the question. Don't confuse the question with the answers. This is the question. Here also this is the here also this is the question. Don't confuse the question with the answers. In question you can use many gates, but in universal environment you use only one gate, one type of gates. Why these universal gates? So why these universal gates? You should know. When creating ICs, integrated circuits, it's easy to convert to single type of gates. This is universal gate IC. you can see when there are logic circuits, it is easy to create ICs using single logic like this. So how you create if you have IC like this? මේ වගේ IC එකක් තිබ්බොත් මට කියන්න කොහොමද ඔයාලා මේකෙන් හදාගන්නේ half adder එකක්. දැන් මතක නම් මම දැන් කියන්න ඕන. කොහොමද ඔයාලා මේකෙන් half adder එකක් හදාගන්නේ? මෙහෙම IC එකක් තිබ්බොත් ගණන් එකතු කරන්න පුළුවන්. half adder එකක් හදාගන්නේ කොහොමද? Can you remember what is half adder? Can you remember this? We did this. Yes, this is IC 7400, very small IC. How you use this kind of IC to create half adder? Like what IC එකක් ඔන්න කඩෙන් ගන්න තියෙනවා IC. Logic gates you can't take, but you have ICs. Inside IC, the logics are working. Now, how we are going to create half adder using this? Can you remember the half adder? What are the circuits? What are the logic gates needed for half adder? There are two. Can you remember, guys? ඉන්නව නේද? නිදිද? Hello? Hello? Are you there? Right. Half adder මතකද? Half adder මතක නැද්ද? Right. Half adder මතක නැත්නම්. Okay, now it's sleeping time. Half away. You're almost gone. Okay. So let's remember the half adder. If you have two inputs, so you have to write in half adder basically you have two inputs A and B. You have to write the sum and remainder. Right. Sum and remainder. එකතුවයි ඉතිරියයි. එක ලියන්න ඕන. බිඳුවයි එකතු කරාම කීයද? එකතුව බිඳුවයි ඉතිරියයි බිඳුවයි. So if you add 0 and 1, එකතුව එකයි ඉතිරිය බිඳුවයි. ඊළඟට if you add 1 and 0, it is 1, remainder is 0. And if you add 1 and 1, what will be the sum will be 0 and remainder will be 1. So can you remember this?
Yes, sir.
Okay. Remainder can be taken by using which gate? Remainder, let's make it another color, just easy to understand. So this is remainder. Remainder can be taken by using which gate? Yes. Remainder
AND
can be
gate.
yes, and gate. There is 1 is 1. 1 is 1. That is AND gate. Some can be taken using which gate? Some can be taken using
XOR gate.
XOR gate. XOR gate. XOR gate can be created by using. So you know XOR gate can be created by using AND gate and OR gate. මේ තියෙන ඇත්තටම XOR එකක් නේ මේ තියෙන්නේ. So this is XOR gate. So here A and B not A not B. මේකේදී ඔයාලට මතකනේ truth table එක. So this is the truth. What is the truth table for this one? A not. So if you can remember this one, this gate, when it becomes 1 0, this will output 1, and 0 1, that will output. So this is type of XOR, right? So let me show if you cannot remember. So A and B not. So let's create this gate. Let's create XOR quickly. And this is XOR. In XOR gate, you have A and B. So let's do quickly. A and B, A XOR B is A XOR B. Let's create XOR and using and truth table for the XOR will be here. False, true, true, false. False, true, true, false. That is this one. False, true, true, false. False, true, true, false. That is sum. XOR can be created using. Let's create using here. You have an AND gates. Now you have You don't have anything. You have NAND gates to create XOR gates. Hari. Then adamuko NAND gate again. Yes. I'll use this one, two NAND gates, and this one. Let's combine like this. Let's combine like this. And use another NAND. This. To merge. Similar to this one that we did here. Can you remember this one? Here. This is behaving like XOR. So let's recreate that. There are easy ways, right? There are easy ways. Let's create using our experience. There are enough easy ways, but this is our experience. Let's use experience and later make it easy, right? Now experience, we have connected this one and this one together. And then again another NAND gate. This was our experience from the previous question and the bulb. Now let's take the truth table of this and check whether are we getting the same XOR output. Highlight, take the truth table, false, true, true, false, false, true, true, false, the same output. That is XOR, this one. But there might be easy methods, but this is how we have done in the previous example. Now you know you need 1, 2. So can you reduce the number of gates? Can we reduce the number of gates to create XOR? Is there any way to reduce? No, 2 gates are not there in the same path, so you can't reduce here. This is anyway, this gate is AND gate. Yeah, you don't have 1 0 0 1 0 0 1 1. Okay, let's use this experience to create half adder. Let's give a try. Not sure whether we can. Let's give a try. AND gate. AND gate can be created by combining 2 gates. AND gate එක නම් හදාගන්න පුළුවන් මෙහෙම කරොත්. NAND එකක් මෙතනින් අරගෙන ආයේ ඒකෙන්ම අරගෙන මෙහෙම join කරොත් 13නුයි 12නුයි යන එක 8ෙන් එනවා AND වෙලා. Because this is NAND and NAND will create AND. XO is the problem. XO is the problem. We need NOT gate. Any NOT gates? No NOT gates. Let's create one NOT gate here. Make a NOT gate. So let's create a NOT gate from using this one. මේ දෙක merge කරාම එනවා NOT එකක්. එතකොට මේ තියෙන්නේ A නම් if this is A and if this is B, let's combine this. If this is A and if this is B, if this is A and B, now A and B, remainder will come from here. This is remainder. So you can take remainder. You are lucky, you can take the remainder. Remainder can be taken by this point. From 8, you can take the remainder.